Hello, this is a demonstrator to show how easy it is to use Jiva's Agentic AI platform to build an AutoML regressor to predict student performance. So the data set we have used is from Kaggle, which is an open set data repository. And what we find here is a data set of about 10,000 students, and we have various features of how in terms of variables. And so we've got hours studied, previous scores, extracurricular activities, sleep hours, sample question papers, and then finally we've got the performance index, which is what we're trying to predict. So let's see how easy it is and how accurate and quick it is to build an auto ML model and test several different models and see which one is the most accurate within Jiva. So we start off, as you can see, here's what I made earlier, but we will build a new workflow called student performance AutoML. And the first thing we will do is bring the data in. So you can see I've been building quite a lot, so we can just have a quick look at this. So this is the data, so the hours studied, previous scores, extracurricular activities, sleep hours, sample question papers practiced, and finally the performance index of the student. So I'm just going to bring that into Jiva. And how Jiva works is the backbone is made via nodes. So each of these nodes does something. You can see the column headings on the left. So you got input, output. Where is the data? Is it on somebody's software? Is it an online file? Is it an RSS feed? Do we need to convert the data? So these are all nodes that do different things to bring the data in and, if necessary, convert it. And then, of course, you've got data engineering nodes. So if you've got imaging and you need to segment it or section it, if you need to split up or change your columns, if you need to adjust things, if you need to extract your pixels, you can do all of that over here. Model training wise, we're an agentic AI platform. So that means we are non-specific and agnostic to AI techniques. So it doesn't matter if you're trying to do machine learning, large language models, intelligent document processing, image analysis, regression, all of these nodes. We have all these different models that do several different things. The one that we're concentrating on today, are the AutoML regressors. So this will test several models and tell us which one is the best for this particular problem. Okay, without further ado, let us get started. So I'm just going to, I've brought the data in, as you can see. And the next thing I'm going to do is say what my inputs are and what my targets are. So we just take off the performance index. And what we're looking for, what our label column is the performance index. So next we will split the data. So we will use an 80% splitter. So 80% goes to build the algorithm and 20% is kept back and blind to test the algorithm. So I'll just change it over here. And next thing I'm going to do is put in an encoder, if I can find it. So there you go. So this will basically convert anything that was non-numerical into numbers or binary. So in this case, I think extracurricular activities was non-numerical. So we will just convert that over. The other thing I'd like to do is anywhere where there was missing data, I'd like to put an average into those rows. So I'm just going to select all, but I'll take out the performance index. And I'll introduce a normalizer. So this means that it'll just normalize the columns. So where you had large variations, we will normalize all of those columns into 0 to 1 scale. And next, we will use an AutoML regressor. So I'll put ChatGPT on. Brilliant. And then next, I will just connect up all of my nodes. And I'm just going to run this. Okay, I'll just pause this video as it's running. And as you can see, here's one I made earlier. It took about 51 minutes to run. And what you're able to see is that I ran through 9 models, and the K-neighbors regressor was actually the most accurate model. When you look at the visualization, you'll see the model, the K-neighbor regressor, was actually very accurate looking at the individual student performances. So we've managed to test 8 different models, and we found one that was actually the most accurate. And indeed, you can almost see it fits right through the middle of the line. And that's an example of how easy it is to build AutoML within Jiva's platform.